name's Alex Rodriguez, reminding you,
You don't need a contract. You need a team of pros.
my name's Alex Rodriguez, reminding you,
You don't need a contract. You need a team of pros. Hey, what's up, folks? Alex here with Bay Cities Construction. Today we're talking about house bolting, how to do a house bolting on a house that has a cripple wall. You may be thinking, what's a cripple wall? Well, stay tuned. I'm going to go over the entire thing with you. We're going to go over some case studies. We're going to go over some of the hardware. We're going to go over the process, everything you need to know about house bolting a house with a cripple wall. Do not go anywhere. Hey guys, we're back. Today we're going to be talking about house bolting, and before we start, I want to thank you on YouTube because we've reached the 1,000 viewer mark. It's really helped us out, and we totally want to share some more awesome content with you. So if this is the first time you're watching this, please smash the like button below, the subscribe button below, and if you have questions, put them in the comments. Either me or Brian will always get back to you and answer your questions. And let's get started. So let's go.
So thank you to all of our new 1,000 subscribers that we just reached recently. Thank you to all of our subscribers. Hey guys, this is Brian. I just want to thank all of our subscribers. We just hit 1,000 subscribers. So we want to commemorate that by going live. And today we're going to be talking about seismic retrofits for residential family homes.
That's what we're talking. That's what we're talking. We're talking all that and more. All right, so we're on. So Brian's put together these really awesome slides. I hope you like them. Please share your thoughts with us. Let's get started. We got a lot of stuff to cover. So for those of you that don't understand what a cripple wall is, it's basically this area here between the concrete footing and your floor system. All right, basically that you have a small wall. And that wall will actually crush under the weight of the building, or it can if the earthquake is really strong. So there's things that we do to it to strengthen that wall and provide some rigidity. All right. So this is a very typical cripple wall. And as you can see on the top here, you've got the floor system, you've got your cripple wall, and the reason that this wall is so weak is this connection right here between the studs and the top plate. It's being held together by nails, normally 2 nails. Some of them only have 1 nail. And then the bottom connection here, the bottom connection down here, is some of these houses aren't even bolted down, right? So if the earthquake can make this stud slip, and it'll cause a failure in the actual cripple wall. So let's look at a few other examples. In this case, there's a little perimeter kind of retaining wall in front of it, and the stem wall is behind it. So this is just to kind of recap. You've got the floor system, you've got the top plate, you've got the stud, you got the bottom plate, and then you got the stem wall. All right. This is a different view, different house. This is a single-family residence, and there's little tiny, I would say other cripple walls that help distribute the weight of the house. So these have practically no lateral strength, okay? So lateral strength is left and right, okay? And that's the type of force that an earthquake will produce, right? It's going to produce lateral force. So let me show you what we're going to do to them. Simpson put this, Simpson Strong Tie makes these really cool connectors. And
shout out to Simpson.
Shout out to Simpson. You guys make some really cool stuff. We use the plates. I can't get my mouse. Okay. We use the plates to tie the wood to the masonry. Okay, and Simpson makes those plates. They also make the hold down bolts and these little A35 clips. So typically what we do is we put a structural one plywood sheet on the boundary of the cripple wall, and then we attach the A35 clips there, and we bolt down the mud sill before we install it. Now, in areas where we can't actually bolt down, we will put this plate that you see up here. That plate, so they make two different kinds of plates. They make a URFP, and I forget the name of the other plate. So one is a flat plate, and one is kind of like an S plate. So you'll see it in some of the other jobs that we've done. In this scenario, you have a kind of a pretty big cripple wall. So this section here, under this post, there's kind of like an interior cripple wall, and you can see that the systems, the beam systems that are holding up the floor joists, which is this area up here, they're just being held together by nails, right? With a lot of lateral force, that connection can definitely break. This is another example of same house, different section. So here you've got a step up in the masonry wall, and you've got your cripple wall there, and then there's this brace. So we would actually remove this brace because it's sticking outside. We would remove that brace and replace it with the plywood, and everything would get plywood, a plywood sheathing. So your seismic force would be in this direction. Okay. By the way, as we go, if you have any questions, please post them in the comments below. Don't be shy. We answer the questions even after the broadcast. In here, these are some internal piers and posts. So this is the pier section, masonry section. You see there's no metal connection to that, and there's nothing connecting that other than maybe a few nails. Here, this one's got a couple of nails, but that's it. So you would definitely want to strengthen that a little bit, maybe just put a post cap on that. Now you do have to understand that when you fix the perimeter would have to break before you break anything on the interior, right? So some engineers would argue that you don't necessarily need to do a lot to the interior posts and piers if you strengthen the exterior of the building properly. But other engineers, they like to have a little bit of redundancy in the system. So it's almost a lot of it will be dictated by your budget, right? The more work we do, the more expensive it is. So you as the homeowner have the option of determining how much you're going to spend, and a lot of that has to do with how much you do. All right, so this is the other plate that I was telling you about. This is the URFP plate. I call it the S plate. And it's got this kind of really cool curve here, and it solves a lot of problems. That other straight plate, we never use it because very seldom is there a site condition that is perfectly flush. So this little S plate allows it to allows you more flexibility, because the mud sill in some jobs it's recessed in, and that plate allows you to go in a little closer. So in this diagram that Simpson put together, you can see that there's plywood, there's an A35 clips. This above here is your floor joists. So above you is the living space, right? We're kind of in the crawl space right now. And this is your mud sill, and then this is your stem wall. The spacing of these plates is determined by a couple of things. It's determined by how heavy the structure is, and it's also determined by how close you are to the nearest earthquake fault. And so there's different zones, and the engineers have access to these maps. They can tell what zone you're in, and there's basically a guidance of the spacing for those plates. Now understand that the brace and bolt is completely voluntary. So some people, they don't even get a permit for it, even though for the most part LA says you have to. Just understand that if you want to have the most accurate kind of assessment, it should probably be done by an engineer, although it's not required. LA City has some set of plans that are kind of pre-approved. You end up picking different components, you end up picking like we're going to use no cripple walls. We're going to use these plates. So there's a bunch of little details on there, and when we have a meeting together, I can share that stuff with you. But they basically made it easy for just about any contractor. They can pick out which system they want to use and put it together and submit it to the city, and a plan checker will look at it. And it basically is a way for the property owners to not have to pay an engineer to do the plans for them. So you have some options. I think if you're kind of a risk adverse to risk, you may choose to have an engineer do that for you. So I want to share with you, this is a project over in Anaheim that we did, and you could see that the floor system is actually solid wood. They're solid TNG, real thick wood. And our engineer looked at this and he recommended that we put these straps in, and that's basically going to keep all of the wood together. It'll keep it from separating. And this ledger board is strategically placed around the building, and it's going to transfer the weight. It's going to transfer the connection between the subfloor to the ledger board to the stem wall, and then the entire system is being held together from the top plate, from the mud sill to the concrete parts. So those are some. This is actually the first time that we saw this type of a framing system. So it was actually kind of a cool project to do, even though it's really tight under there. And no, I didn't fit under there. I mean, I did, but like kind of from here in. That was it. We have luckily we've got Jerry, Jerry's our mole, man. He could just get in under those houses. And anyway, so let's kind of keep going with this. We've got in this one you can see the full assembly. You can see that there's a plate. We've got the ledger board. We've used pressure treated lumber so it doesn't rot. We've got the bolts in there, and then we've got the strap on top. And that strap is continuous. It runs the entire length of the building. This is another angle, kind of a wide shot. The homeowner wanted a little bit of insurance, so we put those little caps in. And that's basically just going to keep the pier from tipping over. If you didn't have that little cap, you could potentially have the pier tip over. When we went over to Ridgecrest after the earthquake back in July 4th. Well, we were there, July 7th or something like that, a few days after the earthquake. A lot of the trailer parks had these piers, and they were not attached at the top. Well, not all of them. Some of them had kind of like this earthquake safety attachment, and it basically kept the top of the pier connected to the trailer, and none of those trailers fell. But the trailers that weren't attached, they fell. So as a safety measure, we put in this little T post cap on there, and it's good to go. There's a little close-up of Simpson's product there again. Simpson makes all the cool stuff. All right, so let me show you a little quick video of Jerry, what? Okay, so let me walk you through this video. We've got Jerry, our expert installer, and he's our back. Anyway, check it out. Check out Jerry working. So on here, you can see Jerry's putting in the strap, and we're using small nails so that it doesn't go through, right? But that strap is continuous. You can see it goes all the way to the end of the wall. Is that it? That was kind of a short video. Okay, let me give you another quick recap of the video here. So every time you put one of those nails in, it connects one board to the other, right? And we did that on all sides of the house, by the way. So it worked out pretty cool. Get out of that screen. This mouse is super slow. All right, next one. Whoa. Do you guys have any questions on that? What do you guys think about that? Jerry's awesome, man. All right, so this is another assembly that we use. When the house is particularly heavy, we do this horizontal blocking, which is what you see here. and we tie that blocking to the mud sill, and then the mud sill we tie it to the plate, and then this gets tied down to the stem wall. It's kind of a wide shot of that. We put these really long, in this job we put these, I think these are LS90s. I believe those are LS90s. Those transfer a ton of seismic force, of lateral force. The corners are really important, that you put one on each corner. Okay, now this property here, this is actually my parents' place, okay? What you see here is a house built on a cripple wall. It's a 2-story house. And for those of you that have a soft story building and are only worrying about the opening, this is the kind of damage that you could suffer in the other part of the building that you didn't do anything to it. So this right here, this large horizontal crack that runs along the top of this electrical pipe, that is where the house shook and the cripple wall started to separate from the rest of the building. Okay, you can see it's completely cracked on both sides. And this cracking is in several of the walls of the building. So let me show you what we did there. So in this case, what we did is we put in new blocking. When you see that new wood that's in here, this is all 3x4 material. And we did that to the entire perimeter of the building. And eventually we're going to put some plywood on top of that. This is a job that's ongoing as we speak. So, but I wanted to share this with you because it's actually a really cool example of not only a cripple wall scenario, but a house that was damaged. And I want you to bring your attention to this crumbled concrete down here. So in here, it looks like from the outside there was some water pooling there, and it eventually got into the concrete and it actually corroded it. So that corrosion caused it to blow out, and this is what you get. If we were to just retrofit this and put in the UFP plates and connect the mud sill to the concrete, this would just slide off. This concrete is completely sheared. It was sheared all the way through. It goes, you could see that crack on the outside of the building. So we ended up doing something crazy. We took the concrete chainsaw to it, and we're replacing the entire section that was damaged. So check this out. This, you have to have some pretty specialized tools to do this. It isn't just having a jackhammer. So let me kind of share with you what we got going on here. So this right here, before I start the video, this right here is just kind of picture somebody slicing a loaf of bread in half. Somebody's slicing a loaf of bread. So that's what it is. That foundation is literally sliced. You're getting a profile look of the foundation. And you can see here that all of that section got blown out as a result of the damage. Okay, so let's check out the video here and I'll walk you through what we got. So there's your horizontal. You could see the iron on the left part of the screen, and that's basically where the foundation literally fell apart. And with that shaking that it had, see, you can see the rebar was exposed. It's completely damaged. We haven't edited this video. I just kind of took it in the field and brought it over here. So this is that post is holding up the house right now. It's a temporary beam and post, and you can see that we've put plywood on top. So we're going to replace all of that damaged concrete right now. That's the next step is we're going to replace another 7 feet. So we have the house propped up in the air right now. Look, that nail, that's the only connection that this house, the building, had to the concrete. A series of nails like every 3 feet. That's it. That's why we were having so many. That's why this house moved so much during the earthquake. By the way, it's super heavy. It's about 1 million pounds. So you can see some of the nails sticking out, and then we cut the concrete. See, we had already put a plate in there, and we removed the concrete that it was attached to. So it's pretty. You have to have some pretty specialized work. So this is me holding the camera on the outside now, and the guys have demoed out all of the stem wall, and we're going to re-pour the whole thing. So to the right there is we used a concrete chainsaw to separate the footing from the stem wall. So right here,
That's the end of the video.
yeah, it's okay. So this is your stem wall, and then this down here is the footing, and they were poured at different times. And there's no rebar in here connecting the footing to the foundation. So the scenario is not so good. So we cut back all of the stem wall that was damaged. We cut back all of it back, which is what you see in the picture below. And if you can see, we got a nice clean cut. We have a concrete chainsaw. Literally, it's a concrete chainsaw. Maybe you've seen it in one of the other videos. And we just plunge cut that piece of concrete, and we take it off like a slice of bread. Or I mean, I guess a better example would be like a slice of cake, because we're literally cutting and removing. So that's what we did. So it's kind of a cool. You have to have about 10 grand worth of tools to do that job right. So here what you see here is the two plunge cuts, right? Those are the two plunge cuts. Whoops. So that's a plunge cut. That's a plunge cut. You can see how it's cut nice and straight, and then we just removed this. We jackhammered this entire section here, and it came off pretty easily. That top stem wall in that section was damaged quite a bit. It's really hard to tell how much damage you have until you actually get into it. So we're probably removing twice as much of the stem wall as we originally planned. I think we were thinking we were going to remove like about 5 feet of it, and we ended up removing about closer to 14 feet of it. So in this picture you see Jerry, we're doweling in, we're cutting holes to epoxy rebar into the part of the footing that remained. And that actually looks a lot deeper than it is. He's actually kind of kneeling down. That, for anybody who works at OSHA, don't panic. That thing's only about 22 inches deep or something like that. We're not going to lose Jerry to a cave-in. Okay, so this is we got all this stuff set up here. What we did, this is a kind of a downward looking shot. There's a concrete form on there, and the rebar's in. We still have to vacuum out the hole a little bit, and there's some debris that fell in the hole. And before we pour, we'll definitely get that out. So for those of you that are hating, you can keep your hate in your pocket. Don't worry about that. So we're really trying to give you an example of how we want to connect the stem wall to the footing, and in a way that will work, right? So anyway, that concludes this video. We're going to be posting some more videos as we progress with this project, and I hope that you found it informative. If you want to learn more about retrofitting, you can visit us at softwareretrofitpros.com, and we'll also post a few links to some other videos on this page. And please, if you haven't done so already, subscribe. We need your support. We want your comments. We're here to educate you and help you understand how we do these projects and why we do them the way we do. My name is Alex with Bay Cities Construction Mining. You don't need a contractor, but you do need a team of pros. Remember, if you want more information, you want to contact us, check out the information on the screen. We're on Yelp, we're in House, we got Google reviews. So please when you're doing your due diligence, we're all over the internet. You can find information about us everywhere, and we'd love to talk to you and answer any questions you have. If you've got some plans that you want to get done, or you got approved with the Brace+Bolt program, give us a call. By the way, we're certified. We're FEMA certified. So, yes, it was a multiple choice test. It wasn't that big of a deal, but it is kind of cool. So, if you have any questions, please give us a call. Love to talk to you about it. Alex, Bay Cities Construction. See you next time.
My name's Alex Rodriguez reminding you,
You don't need a contract.
you need a team of pros.